Okay, so let's take a look at these types of proof. We've got direct proof, which is what we're going to investigate in a moment. Other types of exhaustion. This is where you try every possible setup, and if they all work, then the statement's true. Contradiction is where you'll take the opposite view, work your way through it, and you'll get to a point where you'll make a statement that does not make sense. It contradicts what you have set up, therefore can't be true. We've also got here counterexample. This would be quite easy. If there's just an example you can find that isn't true, then you'll have an answer. So it says the sum of 3 consecutive integers is divisible by 3. Well, let's just test that out. 3 consecutive integers, 3, 6. So, yep, divisible by 3. Let's test out another one, 2, 3, 4. What have we got there? So we've got 5, 9. Okay, yep, divisible by 3. But this is not proof. These are examples. I can't continue to keep doing this. So we'll introduce algebra. So let's say n is any number. So I have any number, and then the next number will be n plus 1, and the one after that will be n plus 2. So simplifying n, we've got 3 n's and plus 3. Hold on a minute. This comes to, if we factorise, 3n plus 1. So it doesn't matter what the number is, it's a multiple of 3. Therefore, divisible by 3. Okay, so that one works. Let's try that same idea with this one. So it says the product, this time multiplying 3 consecutive integers, is divisible by 6. Testing this out. So 1 times 2 times 3, right, 6, that clearly works. 2 times 3 times 4, what do we get? 24. Again, works. Once again, this is not proof. We cannot keep doing this and expect to convince someone it always works. They could think of a different answer. Let's try like we did before. Let's add algebra to this. So we could say n times n plus 1 times n plus 2. Right, it was a worthy thing to try out, but we see here that I'm not getting anything that helps me with regards to being a multiple of 6. So we need to try something else. So a logical approach here now. So we could just say, well, if we've got 3 consecutive numbers, looking at this again, by definition, one of these must be even. Every 3, look at this, every 3, at least one of them must be even. So we've got an even in there. So another way of thinking, that's times 2. But if there's 3, at every stage there will be one of them that is a multiple of 3. So like times 3. Now what's the overall effect? Times 2 times 3. Well, that must be the same as timesing by 6. So we've covered our bases, but using algebra was still the most worthy way to start, but it doesn't always help. And then you start again, have a look another way.